Hello, everyone.
Hello,
Hope everyone
everyone.
is.
Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hello, everyone.
Yo,
Hi, Marcus. How are
Hi,
you?
Kathy. How are you doing?
Yeah, I'm doing good. Hope everyone
Good.
is quite excited for today's session. And I think let's directly get into it because we have got some exciting things to show to everyone today. So, welcome everyone to the second episode of our Get Certified DP-700 Fabric Data Engineer series. And I'm sure many of you attended the episode 1 and heard a lot of good feedback about it. So, yeah, we are under pressure today, Marcus. But let's do our best today and see how it goes. So, welcome everyone. Today, we are going to talk about the second part of the series, which is going to be around ingest and transform data. Now, before we start, we will do very quick introduction. So those who don't know me, my name is Pragati Jain. I'm a Microsoft Data Platform MVP, and I'm currently working as an analytics manager at Avanade in London, United Kingdom. My main skills are focused around helping clients build sustainable and scalable self-serve Microsoft Fabric solutions. If you guys want to connect with me, I'm on LinkedIn, I'm on Twitter, I'm on Fabric Community. Just go and hit connect there. Marcus.
Yeah, my name is Markus Ehrenmüller. I'm also a data platform MVP based in Austria, being self-employed since 7 years now and enjoying helping my customers to transform their data to something which is useful to them. And you can also reach out to me via LinkedIn or Blue Sky if you want. So.
Thank you so much, Marcus. But before we start, I think we really need to, tell you guys about our moderators. They are going to be live only in the chat and they'll be supporting you with any questions you have. And trust me, Kevin and Juan are experts in this area. So I'm sure, Marcus, we won't have any questions by the end of the session because Kevin and Juan would have answered everything. So yeah, Kevin and Juan, we are quite happy to have you on board as our moderators. And yeah, good luck. So let's directly go into what we're going to talk about today. Now, this Get Certified Fabric Data Engineering series is split into 4 different episodes. And the first episode happened on Thursday, October 16, which was about implement and manage analytics solution. But today we are going to talk about ingest and transform data. Now, let me just put my screen. Yeah. So yeah, today this is the topic we are going to talk about. Quickly going to the next screen because now, there are few things we would not like to miss you today. Can't miss opportunities. Now, those who are in the chat, before I turn on this slide, few things for you. There is a special offer that Microsoft is running for you, but you have to keep an eye in the chat. You're going to get something good surprise, a good gift for you guys. So keep an eye on the chat, which is very special today. And this is going to be around your Microsoft certification discount. Currently, Microsoft is giving a 50% discount for PL300, DP600, and DP700, but the offer expires on 3rd November, and the supplies are limited. So if you want to get that 50% discount, definitely go and check out this link. And don't check out the current chat because I know there's someone from Microsoft already putting on the surprise for you guys in the chat. Then the next thing, Fabric Data Days are coming soon. There are going to be experts talking about Fabric, and the fun starts on November 4th. If you want to get involved, get engaged, want to attend, go and check out the link, aka.ms Fabric Data Days. The next big thing is coming, FabCon Atlanta next year. So if you guys really want to learn everything around FabCon, know what's really coming around FabCon or Fabric, definitely go and attend this conference in Atlanta. And it is happening from March 16 to 2026. And if you want to save some money on the ticket, then there is a code to save $200 on the ticket price. So go and check out on aka.ms/FabCon to get your discounted ticket. And do check the chat. Next, very important thing. We want to keep this session today very live and interactive. So just keep saying hi from which part of the world you're joining in, and make sure you ask your questions in the chat because we have amazing moderators in the chat to answer all your queries. Now, let's get started. This was all about the certification background, but yeah, now today we are going to talk about ingest and transform data. Now, before I go into this, in this series, what we are going to do today in this second episode of Get Certified series is we are going to guide you step by step to mastering the DP-700 Fabric Data Engineering certification. And one pointer here is we are using DP-700 study guide as a guide throughout this series. So today we are going to cover the second group of the skill, which is ingest and transform data, which covers 30 to 35% of the certification. Let me quickly show it to you. Just flip my screen and show it to you, the study guide. So this is the study guide for DP-700. I'm sure our moderators will be kind enough to put that in the chat so that people can just go and check out the study guide for DP-700 certification. And this certification has got certain sections in there. Now, the first section was covered in the episode 1 of this live series. Today, we are covering the second section, which is around ingest and transform data. And we are going to cover 3 different subsections under it. So let's just go back to the slides again. Cool. So what we'll cover today? We are going to cover 3 different subsections in this particular area. We are going to talk about how we can ingest and transform batch data. Further, we'll go and then talk about ingest and transform streaming data. And then we'll end up talking about how we can design and implement different loading patterns in the Microsoft Fabric environment. So if you have got experience doing this in other tools, it should look very much familiar to you in Fabric environment. Then DP-700 skills recap, a quick recap on this certification. So if you have attended the session 1 of the series, then this will be like a review for you, but let's just go through it because there could be some people in the audience today who are attending directly this second episode. So Microsoft Certified Fabric Engineering certification, I'll be very quick here. It's the DP-700. It's an intermediate level certification, which requires a data engineering expertise if you want to go for it. And as a candidate, you should be, expert in basically within Microsoft Fabric, with ingesting and transforming data, how you can secure or manage your analytics solution or monitor and optimize your analytics solution. And as this is a SaaS platform, so yeah, the key here is that we need to be just comfortable with all these skills like KQLs, SQL, PySpark, and then you're good to go with the certification. And yeah, I'm not just going to go into detail into this because this was already covered in the first episode. But yeah, let's just quickly go to the next part. And yeah, here today, definitely, we are going to talk about ingesting and transforming data section of this certification. Now, DP-700 skills in depth. Now, when it comes to DP-700 skills, then there are 3 main sections. I showed you study guide very quickly where ingest and transform data is the second section of this certificate, which cover a majority of it, which is like 30 to 35%. Here, we are going to talk about 3 different subsections, which I've already talked about. And yeah, you can go to study guide and see details, but I can quickly show you again the study guide. So we can just go through in details what we're going to cover about. So within this particular section, we are going to have 3 subsections. So we'll start with ingest and transform batch data, where Marcus will take you how we can transform and ingest batch data within Microsoft Fabric environment, say using different items like Dataflows, notebooks, KQL, T-SQL, and then how we can also manage shortcuts by implementing mirroring and also ingesting data using pipelines. We'll also be able to see some kind of ready demos that he has prepared, and where he's just quickly go through and show you how you can transform data using PySpark, SQL, KQL, how you can group or aggregate data, or handle duplicate, missing, or late arriving data. So that is what we are going to cover around ingest and transform data when using batch data, for batch data. Second topic we'll move will be around ingest and transform the streaming data. Here we are going to talk about like how this can be done in Microsoft Fabric, and we are going to see some ready demos where we are going to show around what kind of storage and storage engine we should be choosing to land us streaming data in the Microsoft Fabric environment, or how we can use that data to basically further use it for analytics. So we will look into event streams, event house, where we store the data, how we can actually process the data by using KQL, and we'll also see like some kind of real-time dashboards, which are again the ready demo in this section, to see how that can be done within the Fabric environment very quickly with just few clicks. Then the third subsection that we'll be covering will be around designing and implementing data loading patterns. Now here we will look at full and incremental data loads, and we'll also see how we can prepare data loading into a dimensional model, and further we'll look into loading pattern for the streaming data as well. So this was like a quick overview around like what subsections we'll be covering and what those subsections are going to cover in today's episode. So let's go to the next part. So this is something what I just went through, and yeah, I'm sure our moderators have put in the study guide link for the DP-700 in the chat, so you can definitely go on there and look for details in there. So ingest and transform batch data. So Marcus, over to you.
Yes. So quick hint to the moderator. Yeah, my slide deck. Thank you very much, Pragati, for the introduction. Now let's spend some time to look at what ingest and transform batch data means actually. So what we're having here is that in Fabric, we have different options to store the data. We can have a lakehouse, we can store things in a warehouse, even a SQL database. And the cool thing with the storage options is that the storage options are just the options how your API looks like. So how you interact with the data. So you could, for example, run a Python notebook and store something with the help of this Python notebook in the lakehouse. But indeed, it's stored in the one lake, in the layer underneath the lakehouse. So you can then easily use your warehouse or your SQL database and then query the data somebody created in the lakehouse, and then work further with this data. And for example, store another table where you cleaned up the data further or enriched it with something, and then somebody else can pick it up again in the lakehouse. So that's the very cool thing. So with all the options we will hear now in the next couple of minutes, the important thing is, like for if you want to implement something in Fabric, don't be feared away, don't be shied away. The options are not like meant to impress you or whatever, but it's like wherever you are, right? If you like to use Python, then you can use Python. If you're still a SQL guy like I am, right, I can still use SQL to do everything, or use KQL if you run real-time data. So that's a very cool story with that. For the certifications, of course, you have to level up all your knowledges in at least to certain points. Otherwise, it will be hard to come through to a positive exam. With the lakehouse, looks like this. I will demo this later anyway. So this looks like a lakehouse, right? And there's different options in there. I'm not sure how big and small this might be for you. But in this lakehouse, we can have then, for example, data stored as files, typically for a data lake. Here we see a product CSV file. Hope you can read that. I forgot to run zoom it. I can run zoom it maybe. Do this quickly if I can find it. And then it should be readable for everybody. Yes, run zoom it, and then I can zoom in here a little bit. We can sound it. This is the product CSV file, and inside the lakehouse, we can also take this file and then make a file out of it, which we then can be queried, for example, in SQL. So even if we are in a lakehouse, you can still use all your knowledge which you had with SQL and query the data in the lakehouse. On the other hand, if you use this lakehouse, you can also build a data set or a semantic model. So I think this is still an old slide deck we're using here. Now it's called semantic model. It's not called this data set anymore. And also there's no default semantic model anywhere anymore. That's the word here I was looking for. And with that means that you can build a semantic model which you can query, for example, with Power BI, the semantic model, which doesn't load any data to the semantic model, but keeps it just where it is in the data lake. And there's a lake, there's a direct lake storage mode in Power BI into the semantic model. That means we're not importing the data to the semantic model, but we're not querying it via the SQL endpoint and run rather slow SQL queries on the data. But what Power BI and Microsoft is really, really good at is integrating things. So they find a way to read the content of your lakehouse, which is stored in tables in the lakehouse, and technically this is a delta parquet file. They can just read it as it would be imported. So no data is moved, still there in the lakehouse, but we can directly read it. And the performance will be somewhere between import mode and direct query mode, which is a cool thing, if you ask me. Yeah, then we also have warehouses. So the thing is, when do you use lakehouse or when do you use a warehouse? Again, it comes just up to you. If you feel more confident in transforming your data in SQL, then maybe the warehouse is the thing. In warehouse, you can also create tables with SQL update statements, insert statements, delete statements, which you cannot do in the lakehouse, right? In lakehouse, you use notebooks, mostly Python notebooks, to transform the data. You can query it with SQL, but you cannot store anything there. In the warehouse, you can also store things. The idea, the concept is the very same. You have then tables, and under all the layers, there's one lake. So we can just query the same data also with Python notebooks or SQL or whatever. So it's it's not a blind way, just going in one direction and then it's stored there. Nobody can use it anymore, but it's still in the one lake, so everybody has access to the data. And there's even a query, interactive query experience available, so where you can build your queries and join tables and filter things via a graphical user interface, which is a nice thing if you're not confident with SQL. Then again, building your semantic model on top of the warehouse. And rather new, that means not sure when this came out in publicly available, but now we have also a SQL database. That means the SQL database, as you know it from SQL Server on premises, as you know it from Azure SQL DB, which is also available in Fabric. So this is a full SQL database as you know it. And then, of course, independent if it's SQL or not, we have the source control integration, so we can deploy changes, see what kind of changes happened. We can have branches and so on and so forth, and doing professional development when it comes to our data solution. What I will show you, like in a couple of minutes I got left, is to show you a little bit how a notebook looks like, how the SQL endpoint looks like, how we can transform data with those tools when it comes to batch ingestion. That means not real time, but something which runs regularly and then transforms your data. Before we come to that, I think it's a cool ingestion guide, which gives you an overview what kind of ingestion we are having, right? We can either have a data pipeline, especially the copy activity. This is something which come up in the exam, right? You need to be confident when to use the copy activity, and very important that you always point out to these things, right? Is the solution you should suggest should be for people who love to code or prefer a no-code or low-code solution, right? So if you prefer a low-code solution and you do simple conversions or just copy things, then most probably the copy activity would be the solution you want to go for. If it's more complicated, but still the audience who should transform the data is no-code, low-code, they do not want to type anything. They want to need a user interface because that's more comfortable for them. Fabric got you covered, and this is then the Dataflow Gen 2, which has more transformations compared to the data pipeline. And if you're a developer, right? If you want to code, then of course Spark with different tastes, right? We have Spark SQL, we have Spark R with some Python in here, with Scala, and then you can write your code, and there's like endless opportunities because there's endless libraries you can use and facilitate for the transformation you're doing. So keep an eye on that when it comes to the exam, that you know when to use which kind of tools there. Yeah, and this leads me over to my demo. So let's jump over to my demo environment, which should be this one. So So what I built here is like the financials example. I'm not sure if you know the financials example. If you run Power BI desktop, you can just say, I want to try some demo data. That's this financial file. And I use this file to bring it to Fabric, right? What we can do in Fabric. And there's different opportunities, as you can see, how we can work with our data. And let's jump into maybe the PySpark notebook, which I created here. So what we're going to see here is a notebook which transforms this one wide file, this financials file, into something which is a star schema. So we have to split it out into a dimension table, into a fact table. What I did here is just building one filter dimension table, one fact table containing the KPIs, and one date table, of course, right? So obviously, this was not, should have run this before. Now it's like showing me up some things in here. Can we jump to the demo? For example, what we can do in here. So is this what I'm looking for? Yes. So this is like my financials file. So I put this just as a file, as a CSV file in my lakehouse, and then use what we can see here, PySpark, right? This is a notebook, and each cell in here, code cell, could have different languages. Usually you want to keep it to one language and not jump between languages, but you could if you want, and then read the file into a data frame, right? And then I can display this data frame. As you can see here, this is like a wide table containing the segment, the country, and so on, units sold. And what we also see is added was a CSV file. The unit sold is still ABC, as you can see here. This is still a text and not numbers. So this is now, we need some skills in Fabric to import this then further into a pandas data frame, for example. You can also work with pandas, which has more opportunities to work with. Again, same thing. No data was transformed into the correct data type, but we want to keep working on that. So if you jump a little bit further, is that what we can, for example, also do is we can describe the history of this financials table, where you can see that something was created like a while ago, right? A year ago, I built this example. Obviously, you can see what changed in this file, because this is not just a CSV file. If it's a table in Fabric, but it's a paquet, delta paquet file. That means it's compressed. So a CSV file compressed per column. The same idea what Power BI does in the semantic model. That's why if you import it or you're running in direct lake mode, it's sort of the same thing, right? Technically. And the delta portion of the name delta paquet means that it can also track of changes, right? I can update, I can insert, I can delete files, and all those changes we can see here. So the first thing what I did here was like to checking the data types. So I can, for example, print the schema and then see, yeah, of course, something is wrong here because the sale price is still a string. This is not what I want to have here. So I need to transform this, and I can fix the data types with Python, for example. I just run through my unit sold column and then run an expression there. I replace the dot with the comma with the dot, because this is like a German version of CSV file where we have a comma and not a dot for the decimal separator. So I just replace these and then cast it to a decimal file. Or what I did down here, I think it's always the same, right? The casting things to decimals in here. And the date, I just run the toDate function here to convert the date in the CSV file to a proper date, because it's also a string, and I mentioned here what kind of format is used in this CSV file. And after running that, we now see the units sold, for example, they are now numbers, real numbers. The data type is now correct. And then I can apply further steps, right? I can, for example, count on my things, because I wanted to find out what would be like filtered things, what would be things I want to put into dimensions. This is what I did here. And after deciding over that, I filter the columns. And this is really cool. I mean, I'm coming from SQL, right? But Fabric can be very, very comfortable and easy to use and dynamic. So we can have a variable containing a list of values, right? So the select, the segment, the country, the product, the manufacturing price, and the discount band are column names of my financials table. So I've just put this into a table because we will reuse them all the time, because I want to like have only the distinct values of those combinations to store it in the dimension table. I later want to remove those columns from my fact table. And instead of mentioning them in every script, I can just put it into one nice variable in here. So this is really nice. And then, for example, I can select and then star filter columns. So I get only the distinct combinations of my segment, country, and so on and so forth, which forms my dimension table, right? This is later then stored, as you can see here. Putting the filters in here, then I add also a filter ID, because I want to reference my dimension table. And like I'm not sure if you know SQL. There's this identity column in SQL. Something similar is done with this monocally increasing ID here, which I just add to my data set, overwrite the things, and store it then in just as the financials filter. Just as a check for me, I also saved the different other formats, CSV, Parquet, and the data format. But the important part is here, saving it as the financials filter table. And then later, so obviously, there was some error the last time I ran this, obviously, but everything works. We can see the other results as well. And then the other thing is then I want to join the existing table, like my financials table, with this filter table now, because I want to look up the filter ID, and I can then join again, doing a join here on these filter columns, right? Remember the list of column names. And I think this is a really elegant solution which we can build here in Fabric and in Python. So then I calculate some things. So the gross sales, find out that the gross sales is just like the sale price times the unit price. So maybe we can remove it from the resulting data set, and also removing the year and the month. And at the end, I store something like this in again in my, where is it? What's here? All right, here we go. Like write mode, also store this as the KPI table, right? And later I create a date table. We can do the very same thing, and I think I'm running out of time, so there's a lot of things I could show you here, and you should definitely try out in preparation for financials for the exam. We can run the same thing as a Spark SQL, or we could run, for example, a Dataflow, doing the same things in a tool you might know from Power BI. Power Query Online is the Dataflow generation 2, and you can do the very same steps I just demonstrated in here. So I have my financials tables referring to it in my filter step here, and I just remove all the columns I don't need there. I remove then the duplicates and add this index, right, as a filter ID. Again, some credentials are not working. Sorry for that. Let's see if I can have a quick fix for that. So you see some final results, and the KPI as well, right? I just remove those, look up the filter ID from my KPI table, and remove then the columns in the KPI in a graphical user interface, right? So up to you. That's like the big message here. Totally up to you if you want to like user interfaces or you want to code. Both work as fast. There's no backdraft, except that you have better knowledge in one or the other. With that said, I'm jumping back to my slide deck and hand over to Bharati, because she has prepared something for real time, I guess, right? So where is my slide deck? No. But just over to Bharati, right? You can share it.
Thank you. Thanks, Marcus. I'll just go share my screen again. Okay. I hope everyone can again see my screen. Yep. Okay, cool. Okay, so thank you, Marcus, for that fast-forward demo for ingesting and transforming batch data. Now we move on to the next thing, which is around ingesting and transforming streaming data. Now, Microsoft Fabric provides so many, different capabilities where you can bring different type of data and, start working with it. You can start analyzing it, transforming it, generating insights. Now, when it comes to real-time data, real-time data analytics is commonly based on the ingestion and processing of a data, which is like a stream, and it consists of a perpetual series of data. So typically, basically, it's related to a specific point in time of events. For example, it could be like, say, a stream of data might contain details of messages, say, submitted to a social media or a microblogging site, or a series of environmental measurements, that are recorded by an internet-connected weather sensor. So these are something real-time streaming, because you're collecting those events and then, you're storing them like in every second. Or the frequency could be lesser than that as well. In Microsoft Fabric, now this process can be accomplished using tools designed for real-time ingestion, similar to how you might use Azure Event Hub. Now there could be people in the audience who have used Azure before, so this might be very much similar to what you have done on the Azure Event Hub side. Now, using Microsoft Fabric, now when it comes to basically bringing your real-time streaming data to Fabric, now there are certain elements related to it. Now, when we talk about certain elements now, like you can see, there are a few things here like event stream, event house, and so on. Now, when we talk about event stream, consider event stream as a real-time data ingestion process that will consume real-time data from a data source. Now, there could be any data source because there are so many different data sources supported in Microsoft Fabric environment where you can ingest and transform your data. And when you want to store that data, once you have ingested and transformed, now you want to store it to a destination in Microsoft Fabric, then comes into picture is Event House. Event House takes that ingested and transformed data and stores that data, and which is further available for querying as well. Now, if you see this quickly, this diagram on the right, now this is like a very simple diagram in a simple words. I mean, you have like say multiple data sources that are ingesting and processing your data using event stream. Now, basically, we are connecting to a real-time streaming data where event stream picks up that data, ingests it, transforms it, processes it, and then write it back to an event house. And once that data is in the event house, you can go and query that data. Now, when we talk about event house and event stream, like we have SQL or T-SQL, the language that is supported by event house is basically a KQL language. And whenever you store your data in event house, a KQL database is created on top of which you can run your KQL queries to analyze your data. And once that is done, then you can further feed that data to, say, create a Power BI report, or you can create some alerts on your report based on some kind of, activity or, patterns happening within your data. Or you can also create a real-time dashboard, which kind of gives you a real-time insight on like what's really happening with the data over streaming. So this is like a very quick diagram around it. And the same thing, we have got it like here on the sets, like KQL query set. KQL query set is basically a tool where you start running your KQL queries to understand how your data is, or if you want to do some analysis on it. And real-time dashboard, we already talked about. And Activator, again, it gives you feasibility to create alerts on your real-time events. So next, let's move to the next slide, and then I'll start showing you a few things in the environment. Now, when it comes to ingesting and transforming your real-time data, now, as I mentioned earlier, there could be different kind of data sources that you can connect to. Now, Fabric provides a support of variety of data sources. For example, there could be data sources who are external services. There could be certain Fabric events, or you can also connect to a sample data. So basically, to get started, you really don't need to have a real-time data, because once you start creating event streams in Microsoft Fabric, you have got sample data provided by Microsoft, which gets you started how to create event streams. And then you can do certain transformations on the data, like you can filter, you can manage, you can aggregate or do groupings or create unions or joins. Then there could be certain data destinations where you can land your data, like I talked about event house. When we talk about event streams, then the most preferred choice is event house to land our data, but there are other destinations available as well. Maybe you can land it to your lake house because, say, your data engineers want to use that data to write some magic in notebooks and then, further land it for analysis. Or you can also choose derived stream, a Fabric Activator, or a custom endpoint as data destinations. Now, just quickly flip to the environment, just to give you a, idea around how this might look. And let me know if this requires a little bit. Is it clear or it requires more zoom? I hope it should be fine. If there are issues, just put that in the chat. I'll try to zoom in more. So what I have done is this is like a very simple demo I created using the basically publicly available sample data for creating streams within the Fabric environment. And that data is around bicycle rentals. So what I started with was creating a event stream. Now, what event stream does is, event stream is basically connecting to my sample data. Let my event stream load. And once it is connected to the sample data, I'm just, processing it and writing it back to basically my event hub. So let me just make this a little bigger. So this is what my event stream is about. And this event stream is connecting basically to my sample data, which is basically bicycle rentals. And it's just processing that data. And then I'm further writing it down to our event house. For now, just ignore this alerting thing here. We'll go to that in the next step. So this is where my data lands. And if I want to see the preview of the data, which is kind of landing in my basically event house, I can see that at the bottom as well. Like, okay, this is the data around bike rentals. So I can see bike point ID, street. There are a few elements in there like neighborhood, latitude, longitude, the location, and then the number of bikes rented. And then, yeah, we can see number of empty docks, and then even the time of the event it was processed. So that's why it's a real-time data, because you can see every other second I can see some data coming through in. So event stream, basically a process built in to ingest and transform your data. The next thing comes is event house. Once you have ingested and processed your data or transform your data, then you need to land your data to a destination. Now, there were different destinations we talked about, but in this case, I went ahead and chose event house. And in the event house, once I create an event house, it by default creates a KQL database for me. And if you are new with the KQL database, it's fine. I'm also still learning it, because coming from a SQL background, it could be a little different. Okay, these are the way I write SQL queries, but how do I write KQL, right? Yeah, but it's fine. The difference is only in the syntax, and eventually when you keep on learning, you upskill yourself and you get to learn new skills. So it's fine. So once that KQL database is created, you can actually see the data tables here. Like in my case, I ended up creating a few different tables. Like I've got raw data in here. Basically, it is just ingesting the data without any transformations. Then I ended up creating some other tables like transform data using KQL queries. We'll look at those queries very quickly, because we don't have time to give like a very detailed demo, but I would like to explain things as much as I can. And within the KQL database, if I go to this data preview, I can actually see the preview of my data as well. Okay, what kind of data I've got, and even if I go to the tables, and if I just go and click on the tables, I get to see, okay, what that data is about. And then I can see a good preview around as well, okay, what that data is around, what columns it has got, what elements it has got. So that's how you land your data into event house. Now, once that data lands into event house, as we talked about earlier, it by default creates a KQL database for us. And when we create a KQL database, it actually creates a query set for you. Now, this query set is basically where you can write your KQL queries to analyze your data. Now, if I click on this KQL query set, you can see some of the queries I have written here. Like, for example, if I start with the basic queries, like say, if I want to just understand the number of records in my raw data table that I created, I just run that, and then I understand, okay, it kind of shows me the top 100 rows. That's what the take command is doing there. So yeah, different way of writing the query, but still it's a query language within the KQL database. So you can do that and see. If I just want to count the record, then I can run that query on my raw data table, and I can see the number of records that's been stored in that table. Similarly, I can go and start summarizing the data. Like, for example, if I want to write a query and see like, okay, number of ingestions per hour in this particular raw data table, then I can run this particular query, which is summarizing and checking how many how many ingestions per hour have been ingested into this table. So I can run that and see, okay, it kind of tells me with the timing, okay, how much it has been. And then further down the line, I ended up creating a transform data using a logic for summarized data. Then I can do the same things on that table and run the similar kind of queries as well. Then again, same thing. If I want to filter down my data and understand what's really happening with the data, I can do that as well. I can create filters. They look very similar to like we write in SQL or T-SQL languages, but yeah, definitely some difference in the way of writing it, right? The syntax, but still it's doing the same thing. It's just, querying. This query is basically creating a time chart that shows the number of bikes in the Chelsea area neighborhood as a time chart. So if I run this query, then it will just show me a time chart generated for my particular data for Chelsea area. Then I can see, okay, how many basically number of bikes have been rented here. So yeah, we can just go and write those queries in the similar point and understand. We can aggregate the data. We can do so many different things with the KQL database. Definitely it's something new, but it's something you can upskill yourself as well. I mean, that's the beauty of Fabric, right? You really don't have to stick with one technology. Like Marcus mentioned while he was showing notebooks, right? You can write in PySpark, you can write using SQL, you can use R, you can use Scala. So based on your expertise, you can do things, but still you can learn something new as well. So now let's go back to the deck. So this was around the event streams, which we saw. And then I also talked very good. I gave you like an overview around what Event House is around. It stores your basically streaming data, and then it gives you a KQL database where your data gets stored in form of tables. And then you also have KQL query set where you can write your KQL queries to understand and analyze your data in more better way. Then the next thing comes is you can visualize your real-time data. Now, there are two ways you can visualize it. I mean, obviously, those who come from Power BI background, they'll be happy about that. Yes, you can visualize your real-time data using as a Power BI report. And then the second thing is real-time dashboard. You can actually create a real-time dashboard which keeps on updating in real time, showing you peaks or what's really happening within your data in the real-time scenario. So I'll just quickly show it to you, the dashboards I have built in already. So just going back to my environment. So this is the real-time dashboard that I created. Again, based on the sample data, I didn't take time to get my own data because why? To get started, you have got sample data in there. Just get started with it. So you can see like two charts there, very simple charts there. One chart is showing like recent bikes by bike points. So I can see, and you can see less than a minute ago, this chart was updated. Then on the right, I've got a simple table which kind of shows me, okay, number of bikes that I can see within the Chelsea neighborhood. So I can see that chart in here, here as well. And yeah, you can. This is currently in the viewing mode. You can go to editing mode. You can add more charts to it as per your requirement, and yeah, get that going. So it's like real time because it just keeps on updating with the real time. And then the next thing is your Power BI report. So you can create a Power BI report as well using your real-time data. And obviously, Power BI is a component of Fabric platform, and you can create those reports using KQL database. So if you go to your KQL database and let it load. So whatever queries you run in your KQL database, you can actually convert the output of those queries as a Power BI report. Now, what I did, I ran a very simple query for Power BI report where I'm trying to summarize my raw data on these particular columns and just trying to, generate a chart. So what I did was I ran this query, basically. I ran this particular query. And then I want to visualize the output of this report as a Power BI report. So what I did was I just took this. I think there was an option for create as Power BI report. The moment I do that, it converts the output of this query as a Power BI report. So let me just quickly go back to that report. And if you see this report is showing me, okay, number of bikes and, empty docks. So yeah, I can get that working. And if I want to add new charts as well, I can edit it. And once I edit it, I can start moving the data. Yeah, it's just taking, it's still loading. Yeah, while demoing, things are always slow, but it's fine. Okay, I've got 2 more minutes. So yeah, so this was basically my query result, which I'm using to create charts. Now, this was one of the chart I created, and my query resulted into these different columns. These different columns, and I'm using that query output. Okay, I'll have to run this again, but yeah, I'm using that query output to create those charts. And then I can keep on creating multiple charts and then save this report. So yeah, you can do real-time in dashboarding or Power BI report. Let's go back to the slides again. Oops, where are my slides? Yes. Okay, so we quickly had a look at a real-time dashboard and a Power BI report coming from our streaming data. Then the next thing comes is using Activator. Now in Microsoft Fabric, when we talk about Activator, now Activator is comparable to the tools that basically automate your workflows and actions based on real-time data triggers. Now, if you come from like Azure background, then it is similar to your Azure Logic Apps, which is basically a service that automates your workflows and integrates apps, data, and services by responding to triggers and actions. If you come from Power, basically, yeah, Power BI side, or if you've worked with Power Automate before, then yeah, it is similar to Power Automate, because Power Automate is a tool that enables the creation of automated workflows between apps and services to sync your files or also get notifications and collect data. And again, if you're coming from data engineering background, then yeah, Apache Kafka with streaming process is very similar to this. And even if you've worked with AWS before, then AWS Lambda is very similar. Now, Data Activator here in this case allows you to basically trigger actions such as, like, say, you can send notifications, or say you want to, say, start a workflow or invoke a service, then you can create a Data Activator. Or say if you want to get some alerts based on certain conditions or thresholds within your streaming data, then yes, you can create Data Activator. Now, there are a few concepts within the activator. Basically, you create events. Now, each record in a stream presents an event, and then there are certain objects. So real world conceptual objects are based basically on your data values that you get in your streaming data. And then on top of that, you start defining rules so that you can, create some conditions or to trigger basically actions on your data. And then there are field data values to define object properties, which you can reference using multiple rules as well. So I'll just quickly show you a very simple activator I created. So I'll go back to my workspace again. And what this activator is basically doing, it is simply triggering action. We let it load. Oh gosh, it should load fast. Why it is taking time? Yeah. So basically what this activator is doing, it kind of triggers something. So it is basically, just if I show you the tutorial, the alert details. So what it's doing, if my number of bikes are, say, less than 5, then, it just sends me a trigger as a Teams message. And yeah, that's what it is doing. So over the time, if I see number of bikes in the live feed less than 5, then it triggers action and it sends a message to me in my Teams. That's what this simple alert is doing. And now you can modify those rules. You can add those rules. You can also modify the kind of message that it will email you or send it to you in Teams. So there are so many flexibility that you can play around with creating these alerts in your environment. Let's go back to the slides. Yeah. And then, yeah, when it comes to managing your data sources in Real-Time Hub, then there is a direct tab given to you, which you can quickly just go. So if you go to your Fabric environment, there's something called Real-Time. And if you go to that Real-Time, it will show you all the resources you have created using Real-Time capabilities. And from there, you can manage those sources very easily. Like, for example, if I want to see data sources, if I want to see Fabric environments, or if I go to see these things, so it will show me all the recent streaming elements that I've created within my workspace. I'll just better show it to you in the deck because it's showing time to load. So if I go to this, I can see all the recent, all data streams that I've created within the environment. And I can, manage them from here. I can manage the data connections. I can see, okay, what dashboards I've created, or say what kind of alerts I've created. Or I can also see if there are any real-time resources that are endorsed within the organization for me to access. Then further down the line, I think, yeah, we come to the next topic, and then over to you, Marcus.
Thank you very much, Bhagati. Yeah, very insightful, right? What you can do with Fabric, right? Batch transformation in any kind of tools, and also
I think so much to digest.
Yeah. That's the backdraft, right? To learn so many things. For the ingestion and transforming of things. Now I'm looking at the wrong thing. I wanted to jump here, right? Yeah, we already have seen this, right? So I wanted to directly jump to the design patterns, right? So if you load things, of course, you have different options. As we have just seen, we can have real-time load. So you're not really loading everything you get. I think this is like the whole idea of real-time, that you don't load everything. But while you're loading, right, data comes in, you decide on things. You discover patterns. You trigger something with Activator, or store only the result, which is interesting, right? That's one of the things. If we jump back to the batch processing, then we can either decide on a full load or an incremental load. And my first goal is always full load, right? Because that's the easiest. So if your environment allows to load everything every every time, right? To purge everything you have and reload it again. That's the simplest pattern you can have. And if the resources and the size, everything allows for it, then go for it. The backdraft, of course, is if it's too much data, if it takes too much time to process, or if you have like to discover, is there any change, right? Because you reload something and then you want to discover, is it like it was, or was there some change? There's some different patterns, and we will talk about slowly changing dimensions in a second in a demo for a couple of minutes. Then you cannot full load everything because you will overwrite the information you already have and cannot compare the information you had and what's new, right? For the incremental load, that's the goal for if you need to reduce your data transfer, right? If it's just not going through, like the maintenance window is not big enough, right? Because the night is not long enough, or you need to load it like every 10 minutes and it's just not possible, right? Physically not possible to transfer everything within 10 minutes. Then you have to think about incremental load. And there's different patterns you can have here. So one would be that you partition your data and then only load like the last couple of days, right? So for example, bookkeeping, if the month is closed, nothing might change because then you would be in trouble if bookings would change then afterwards. Then you just load everything from this month, right? And from the current month, you purge everything from the current month and reload it again. Also rather easy, right, to do those. So, and the idea is to reduce the whole transfer, but it's more complex. So you need to test this intensely. So not losing anything or not duplicating anything. So everything is it should look like, right? But let's jump to the demo I prepared here, which talks about slowly change the dimension, which is also a thing which comes up in the examination, in the exam. So you have to get an idea what this is. So slowly changing dimension as a term comes from Ralph Kimball, who is the godfather of all data warehousing. He retired in 2016. I hope he's still alive and enjoys life, but I didn't hear anything from him since. And he had like this very interesting concepts and names, and one of them was slowly changing dimension. And the simplest pattern is if we have I want to start this from scratch, creating my source table here just with 3 rows, right? NA, Northwest, and North Kingdom. We're not changing any currently. And then I think about slowly changing dimension type 1, which means I want to keep track of a change in the sense of I want to know if something changed, right? So from one point, what was the point this was changed? But I'm not keeping track of anything in the past, right? And if something is deleted, I don't delete anything. I just soft delete it and mark it as deleted. And if you do so for the first time, of course, only the insert would happen. So what the insert does is just looks up my table where I want to insert in. I load from the staging table from a source and just look up if it's not available in the stage, right? If something I'm loading in the stage but it's not available in the data warehouse, then I want to load it. And if I do this one time, I load 3 rows. That's the 3 rows from above, right? If I click it again, nothing happens. That's the most important part here. Nothing changed. We should not load anything, right? And if I now take a look on my table here, the select where's it, delete, here we go, so change dimension 1, then I just have those 3, and again, this is too small, right? I heard you, but I did read it too late. So 3 rows inserted at the timestamp currently we are at, right? If I then jump back and do some changes, so for example, one change is that something was deleted, it's not available in the data source anymore, something changed. Northwest, I changed it to German language, Northwest. Or I introduce, of course, I'm Austrian. Austrian is missing, so I insert Austria here. If I run it again, jumping to my concept of the slowly changing dimension, I don't recreate everything, but I just run my insert statement, which looks up insert anything which wasn't there before. I update everything which is there but changed, right? So I'm looking for changes where the region, for example, changed. And sometimes we have to be very specific here. If this is nullable, we need to be really careful. With the newest version of SQL Server, it also allows you to do a comparison if something is null or not, and then make it an easier script here. And the last thing is deleting, right? So if something is missing, we're not deleting anything, but we just set deleted at stamp, right? That's what I'm doing here. And if I run the query again, we should still see now the rows from before, right? Not NA, but this was deleted now with a latest timestamp. Northwest was just changed to Northwest. United Kingdom is unharmed. This is also very important to test this. They do not change that timestamp if nothing changed. And Austria was reintroduced at the same point when we deleted NA. So this is slow change dimension type 1, which is easier, so to speak. The harder thing is the type 2, where we want to need to keep track of changes. So what we do is, if anything changes, so start from scratch here and just shortcut my demo here. So I will run this script here again. Again, everything will be inserted for the new table. Nothing should be available before, and then I have to immediately the change here. So I change some rows, one row, I delete one, and into another one. So the difference here with the script for the slowly change dimension 2 is now that we need to take care of changes in the terms of if something changes, we want to keep two versions of it, the old, the thing before, and the thing afterwards, because maybe you have like sales and you want to keep track of the regions of the sales, but some company moves its headquarters to a different country, and maybe for the past, the sales should not move, but the sales should stay where it was. That's the basic concept of slowly change dimension 2. So we get this a very similar thing here, enables deleted. Now it's not called deleted, but valid until. So keep an eye on the exam when it says from until, then most probably they talk about slowly change dimension 2 as the pattern you need to implement. If it's just update deleted, then it's slowly change dimension 1. So what we can see with Northwest, with the change, we keep the old version, which just say it's not valid anymore, but it's still there. And the new row is then in here. So we can see that Northwest changed from what to what. We can keep track and see the full history. And that's the idea of slowly changing dimension 2. Something which will come up in the exam, I predict, so to speak. So jumping back to my slides and also jumping back to Bracati, like final words. Now, how to implement Fabric? We can have full loads, we can have incremental loads, real-time loads. You have a lot of different tools, and you need to get an overview of them at least, and also in-depth knowledge to master the exam, right? That was the demo. Yeah, to prepare for the exam day. Yes, we already heard it, right, Bragati? Everybody needs to prepare. Before we come to, and there's like two other sessions, right? Like this one, there's a third, and the fourth is then a Q&A session. That's what I believe here. But I think there were some questions in the chat. Shall we take a minute or two on the questions, Bragati?
Yeah, of course. Yeah, we can take the questions also, and maybe we can quickly run through the last slides because we don't have many.
Yeah,
so it will
not
be
running out of time. Yeah, very good.
Quick. Yeah. I think we have a minute or two to go through the last slides. So I'll maybe you can go through the last slides, Marcus, quickly if you want to.
So still my slide deck, which is shown. Yeah, okay. Yeah, then as you heard, no, this is already no, there's two sessions. Yeah, there's one next week, right? Monitor optimizing your solutions, and then there's a last session, prepare for exam day and open Q&A. So if there are any questions, mark this date in your calendar, so you can come up with the questions, right? That's what you have seen before. And yeah, again, don't miss opportunities. There's a lot of chances to learn something about Fabric. There's a discount, a 50% discount, which offers on November 3rd. So be quick. I think you need to use it before that. I'm not sure if you also need to do the exam before that. Yeah, you will see on the slide there. And of course, there's also a Fabric Data Days coming up, a skill fest, with starting in November 4th, and FabCon will but will be the first time in Atlanta, right?
Yes.
So they're moving from Vegas to Atlanta for the US audience, and for the European audience, it will be Barcelona in October. I think this is also already announced publicly. Yep. So, and I think this is the end of the slide deck, so we can jump to the questions.
Yeah, maybe. I mean, let's see if we have got any questions in the chat. I know Kevin and Juan has been amazing answering all the questions like robots. They are just typing in there.
Yeah. There was one from forwarded from Pam, right? One about the environment thing. So if you just decide to create some new environment to install certain Python packages in one workspace, can you reuse this in the other workspace? And the bad news is no, the packages are not the packages, but the environments, they are created in the workspace. So they hosted in there, and you have to recreate it in the other workspace again. And I think the workspace, the name workspace might be like leading to the wrong idea or whatever, but maybe, but as you can see from the semantic models, right? A workspace is sort of a database server, right? And the semantic models are databases inside the server. So there's some, even if you create everything in your Fabric environment, have different workspaces, technically they are like separated things. That's why we cannot just use things from one to the other. Yes, you can have a report using a semantic model from another workspace, because of course you can have a Power BI desktop report using something from another database. This is working, but exchanging things and settings between those databases, workspaces, unfortunately will not work for the workspaces. This is my answer here. And I think there was another one towards you, Pragati. Can you see this? Whether Event House will support time travel to check previous historical data too. Can you see the
Where
question?
is that question? I don't see the question.
You see it in the people, like in the not in the comments.
Sorry.
From 2:32. I also didn't see it while I was talking, right? I was only seeing it.
Yeah, but I still. Oh yeah. Whether Event House will support time travel to check previous historical data too. I think this is something I am not sure about, guys. I mean, I don't know if Kevin or Juan have any idea on it, because I haven't tried time travel yet. And I also don't know if that still exists on the Event House side yet. So I'm not sure about this feature.
Thank you very much.
Yeah, we're almost at the top of the hour, right? Yeah.
Yeah, we are just on time.
Time traveling, right? This was like the keyboard
Yeah.
here.
Thank
I'm just
you.
traveling very fast.
Thank you all. Thank you very much, and have a nice rest of the week, everyone.
Yeah,
Thank
you too.
as well.
Thank you,
Yeah.
Thank
everyone.
you for amazing
Enjoy.
speakers.
Thanks to